So combined power functions look like polynomials, but they have a rational component. So a combined power function is similar to a polynomial, but has a rational component. Or negative exponents. And of course, negative exponents make things rational. It makes fractions. So any functions that include a 1 over x term have a vertical asymptote at x equals 0. So with these types of functions, often you're going to be asked about domain, range, where solutions exist, such as in this example from May 2017. So let's look at it. They've given us no numbers, but we do have c over x. So with our a, b, and c being positive integers, excuse me, the c over x means we can't divide by 0, so x is not allowed to be 0. So can't divide by 0. So x equals 0 is an asymptote. We've seen this over and over again, and we can see it in our picture here a little bit, but we can come in and draw it in. Use your ruler, please. That x equals 0 is not allowed. Let's keep reading. Part of the function is shown. Local maximum at -2, -2. So this point here must be -2, -2. Local minimum at 2, 6. So it's telling me the exact coordinates of those points. And that one was -2, -2. All right. We see there's no graph in between. All right. Keep reading. The domain of the function. So domain are the x values that are allowed. So we see that the graph exists all the way here. It keeps going down. But now, as we go along the x-axis thinking about points that are allowed, so we're hitting all of the negative x values, but we're not hitting 0. I have to lift my pencil to start again. So my domain is going to be x is not equal to 0, and to be thorough, I could include that x is a real number, but not 0. Draw the line. So draw line, ruler. Y equals -6. Y equals -6, that's down here. To hit that line, I must draw a horizontal line. So I'm going to draw y equals -6. Looks like this. I'm going to use my ruler to make sure I go through the -6. All right. Done. Write down the number of solutions to my graph equaling -6. Well, looking at my picture, I see that I cross once, twice. My points of intersection are my solutions. So the number of solutions is 2, because we have 2 points of intersection. Find the range. So now range, I'm thinking y values of k for which f of x equals k has no solution. So when f of x was -6, we had 2 solutions. We're going to have 2 solutions as we keep going up until we hit this point where we would have just 1 solution. But from this whole area here, if I drew horizontal lines in, I would not hit the graph. So my y values go from -2 up to 6, where if I drew lines in, I would have no solution. So between -2 and 6 means that -2 must be less than k, less than 6. So notice I'm not doing less than or equal to, because if I said equal to, that means my line would be here and I would have 1 solution because I have a point that exists there. So between -2 and 6, in math terms, which is how I should write my answer because it asks me my range, so -2 less than k less than 6.